Okay, good evening, children. Now, here we are going to discuss reactions of carboxylic acid. Carboxylic acid, as you know, has got this functional group. So, first reaction that we is anhydride formation. Anhydride formation. Anhydride formation means when we treat a carboxylic acid in presence of say concentrated sulfuric acid, then from two molecules of this acid, two molecules are involved. Say this is another molecule I am writing. From these two molecules, there will be loss of water because concentrated sulfuric acid is a dehydrating agent. So we will get product RC double bond O C double bond O R. This plus water, and this functional group is called anhydride. So this is anhydride formation. This reaction can also happen in presence of phosphorus pentoxide. Phosphorus pentoxide and heat also results in this. Okay, second chemical property let us discuss is esterification reaction. Esterification reaction. What is esterification is carboxylic acid CH3, suppose CH3 C double bond OH with alcohol. Suppose we are taking ethyl alcohol. I am writing ethyl alcohol like this, CH3 CH2OH, ethyl alcohol. Again in presence of concentrated sulfuric acid. So what happens is there is again loss of water, and a loss of water involves OH of carboxylic acid and H of alcohol in the loss of water. It is very important thing to remember. It doesn't happen the other way around. So we get product CH3 C double bond O, then this bond gets connected to this one, O CH2 CH3 plus water, and this compound where we have this functional group, they are called ester. In NCERT book, mechanism of this reaction is there. So I am discussing the mechanism of esterification reaction. So, let us do this general case. This carboxylic acid and this alcohol, say R-OH. We will get this ester. We will get this ester. So let us write the mechanism. Of course, in presence of acid. So the first step is protonation. RC double bond OH, lone pair, and here is a lone pair. First step is protonation, H plus here this H will get attached. So with the help of one lone pair form, so there is now only one lone pair, and this side it is as it is. And this O will become positive. So this is the first step, protonation. What will happen? The second step is alcohol molecule. This alcohol molecule will act as a nucleophile. So I am taking this alcohol molecule, say R-OH. This alcohol molecule acts as nucleophile. It attacks here at this carbon, and this pi bond electron comes back to this. So this is what happens in the next step. Alcohol molecule acting as nucleophile. That results in and this O naturally will become plus. Okay. The next step, all these steps are reversible. Next step, there occurs a proton transfer. Proton transfer, because since this O is plus, this bond electron will go to highly electronegative oxygen, and this H as proton will get attached here. This H will get attached here. So proton transfer will take place, and so it will be R dash O C O H proton transfer will get attached here, O H H, and there is only one lone pair. Here there were two lone pairs. Now there is only one lone pair, and this O will become a positive. Okay. Next step, what happens is there is loss of water, minus H2O. Why there occurs loss of water? Because this, what will happen is, because of this O plus, the driving force, this lone pair will come here. Lone pair will come here. Remember, it was like this here. This lone pair will come here, and this bond will come here. This water unit will go out. So there is loss of water, and that will result in R dash O double bond O H, a lone pair plus so this has resulted. The water has come out, and the last step is loss of proton. So loss of proton will take place because this bond electron will come back here, loss of proton will take place, and we have this one R. I'm writing this one first, R, C, then double bond O. With this C is connected O, and then R dash. So this ester we are supposed to get. Okay, so this is a mechanism of esterification reaction, and this mechanism supports this fact that it is always OH of carboxylic acid and H of alcohol involved in the loss of water. So after esterification, we have reactions with, so let us write the third reaction, it is reactions with PCl5, PCl3 and SOCl3. These reactions are very much similar to the case of alcohol. So I am writing here R double bond OH, carboxylic acid plus PCl5. Okay, here you get R C double bond O Cl plus POCl3 plus HCl. If it is PCl3, then also you get here R C double bond O Cl plus H3 here. Of course, here you have to put for balancing 3. So in this way, SOCl2 now it becomes R C double bond O Cl plus SO2 plus HCl. So these reactions are very similar to the case we have discussed in the case of alcohol. Okay, next reaction is let us discuss this soda lime decarboxylation. Soda lime decarboxylation, it is say carboxylic acid, say R C double bond O H. Actually we don't take carboxylic acid here, we actually take sodium salt of carboxylic acid. Sodium salt of carboxylic acid, when it is heated with soda lime is NaOH and CaO. Mixture of NaOH and CaO is called soda lime. If it is heated strongly, then what happens is there is loss of sodium carbonate, or actually loss of carbon dioxide. Okay, and in the loss, what happens is this R, you can remember in this R part gets attached to this part. You get RH, and side product will be Na2CO. This is a method we can use to decrease the number of carbon atoms by 1. If you see the product alkane will have 1 carbon atom less. So this is soda lime decarbonylation, and now reduction. Reduction, carboxylic acid can be reduced to alcohol. Here we use the reagent lithium aluminum hydride, the first step, and the second step we need water. So carboxylic acid is getting reduced to alcohol, and we can also reduce to hydrocarbon. If carboxylic acid is treated with HI in presence of red phosphorus, and then heat, and if we heat, then we get hydrocarbon, and there is liberation of I2. I am not balancing this equation, that when carboxylic acid is heated with HI into red phosphorus, then it gets reduced to alkane. So this is about reduction. Then in this way, this reactions you can easily learn, that nothing must be explained. Then you will find in your book one reaction is HVZ reaction. HVZ reaction, it is Helm-Wohlert-Zelensky reaction. That this we have to study. And finally, with aromatic carboxylic acid, suppose benzoic acid, since it is an electron withdrawing group, this is a electron withdrawing group. So when we carry out electrophilic substitution reaction, the incoming group will come at the meta position, and we will get meta product. So suppose if we carry out nitration of this, we get nitro product. Now, one important question that can come in exam is that aromatic carboxylic acid, they do not undergo Friedel-Crafts reaction. Okay, they don't undergo Friedel-Crafts reaction. It is because there can be two reasons for this. Number one reason is that it's highly deactivating group. Highly deactivating group deactivates the ring, and another thing is that in Friedel-Crafts reaction, we use AlCl3 as Lewis acid. This AlCl3 forms an intermediate by reacting with COH. With this AlCl3 combines with carboxyl group and prevents further reaction. So Aromatic carboxylic acid does not undergo Friedel-Crafts reaction. So these are some of the chemical properties of carboxylic acid. There may be a few other also that you can easily do it. So this much for now. Good night.